Bismillahirrahmanirrahim. Assalamu alaikum students. Now this is question 7 taken from 9618 A-level computer science May June 24 series, and paper is 2 component 3, that's sorry 2 paper 2 and component 2. So this question number 7 usually is on STD, structure state transition diagram or structure chart, and this question number 7 usually A part involves more of your reading skills and carries less marks, 3 to 5 only. This one has 3 marks. Okay, but I was about to skip this because I was directly wanted to take you to this one. Seems very horrifying, but we'll do this today. So now let's just quickly go through this. If you see the system, this is a fitness club, has a computerized membership system. The system stores information for each club member is your concern. Has a name, home address, email address, mobile phone number, date of birth, and exercise preferences. And now many classes are full and the club creates a waiting list for each class. The club adds details of members who want to join a class that is full to this one requires more of your reading this part. Okay, when the system identifies that a space is available in one of the classes, a new module will send a text message to each member who is on the waiting list. So now decomposition will be used. Decomposition was a procedure, was a method used in one of the 5 stages of system development life cycle, which was analysis, design, coding, and testing, and this one is used in analysis phase. Decomposition and abstraction. Now will be used to break the new module into sub-modules. Sub-problems identify 3 sub-modules that could be used in the design and describe their use. Now since if you look at this, it gives you this big 4 lines, sub-module and their use, fine, but sub-module, what it's asking, identify means just give the name, or maybe you're supposed to write the header just like this. So I would say it says that will send a text message. So sending a text message would be one module. Creating a text message or sending, you may say module means function or procedure, so we can just write the name. That will be create message, and that's it. If it's asking some values to pass, we are not supposed to answer this because there are only 3 marks. I've already seen it, so you should also take a look at the marks and should not be wasting more time than it's expected to. So now then you can tell why it's used to create a message based upon something, user name and their phone number, that's it. Now the other modules could be, send message, create message. You can always say what was the purpose or use of it, and you can also say if you look here, club waiting list for each class. The club adds details of members who want to join a class. So identify a member maybe, and could be that's full to be waiting list for the class. You may also say there could be so many sub modules that you can create from this. So when the system identifies that a space available is one of the you can also use this one. Identify a member, okay, and a new module to send. Yeah, so there will be couple of sub modules. Let's just say this one would be identify a member. You're not supposed to put any spaces like this. See, this one is a name of a function or procedure which follows the same rules as a identifier or a variable. So you may say underscore or a dash like this, but I would suggest not to do it. Just write it like this, and should be a meaningful name. You cannot just say identify AM. That does not say anything. Identify a member, yeah, that's fine, and put bracket like this, and then you can explain the use of it. That's it. I don't want to spend more time on this. Let's just move ahead. Okay, now this part. Now this is seems to be an STD, state transition diagram. The topic was finite state machine in unit number 12, and this diagram is used to show what was the states of a system, of a program, when you follow the logic, when you go through the program. So what states or stages, and what uh, you know uh, those variables or what values are making it to change to a different state. Okay, so finite state machine, an end state from state 1 to state 2, what factors affecting this one. Usually this one represents a separator. This left hand side would be input, and or resulting output will be on the right hand side. Okay, so now it has given you this diagram, and in this diagram it has asked you to complete the table to show the inputs, outputs, and next states. Assume that the current state for each row is given by the next state. Okay, next state is here on the previous row. For example, the first input A is made when in state S1. So when it's S1, there was no input or output, and you usually start this. I'll make another video in which probably you would have to fill such diagram, and you would have been given this table. But in this particular question, you are given this diagram, and you're supposed to fill the table. So it could be vice versa. And now this one shows a start. In the case of a structure chart, this one would show a Boolean value being passed or being returned. But this in a STD, this one shows a start. So since it does not have any for the state 1, it does not have any input and output, so this is what they have graded out. Now this one is solved for you already, so you may start when you going from S1 to S3. See, S1 to S3, you are it says input A. So in the input column you would say input A, but since there was no output shown, so you would say none. Okay, this is what it says here, that you can consider this S3 to be coming from S2 if it comes right after this. Okay, now we are supposed to fill these, the next ones. You may assume from S3 is the state that we are standing right now, and now the possible, and you would also take a look at this output W, wherever it's going to S2 or S1 or S4 or whatever, or even repeating looping to S3. This one should be a factor mentioned over there. Now you see, from S3 we have output W. Okay, it was here, output W was the output. Now standing at S3, output W is used to loop into S3. And what else? This one did not have any output W. And what else? This one no, because that would be it. See, it's transiting from S3 to S3, where there is an output W, and we are supposed to fill input A. So let's just say here is transiting from S3 to S3, and this one I believe was input A, right? Dash A. So completed. Now assuming you're standing in S3, and from S3 to goes into next state, the output should be none, and you can take input and some other state. Now standing at S3, we cannot go back like this, and this one is already done. So this is understood that you would have this. We had no input, no output. Output was none, so this is the case where we have no output. Input is B and going to S2. So this is what you would do. Next state would be S2, from S3 to S2, and this one I believe was input B, right? Dash B. Okay, now you're standing at S2. Alright, from S2 you should already take a look. From S2 to go somewhere else, you would see a transition, or you would see a path which would have input B. Okay, standing at S2. Now S2 would have input B to transit it to S5. It cannot go here, it can go by the way here, but should be input B, this one is input A, so we cannot take this one, and all the other connecting, they are coming towards S2, not going back to S2. So this one is the only one which has input B, has no output, and going to transiting to S5. So from S2 to S5, okay, and there was no output, you can say none. Oops, none. That's it. Now you're standing at S5. From S5 to go to some other state, input should be A. Okay, look, stand at S5 and see whatever taking you to input A, and this one is input B. We cannot take this path, we cannot go back, so that's the only one that has input A, which was already given. So we would write output is none and transiting back to S2. Okay, remember it was input A and you coming here to S2 back, and there was none output, filled it out. Now look at S4. To go to S4, we already know that this one is the most easiest one. We know that we are standing at S2 and we have to go to S4, so whatever the input and outputs are, we are supposed to write this. Let's take a look. S2 to go to S4, I mean, you can try to see if other possibilities. We cannot go back to this A, we cannot go back to this because this arrow pointing towards S2. We could go to this one, but the transiting state is already given, which is S4. So this one is taking us to S5. We cannot take this one. Now from S2 to S4, that's the path, valid path, and we are supposed to fill input and output on our own. So we can say input A and output X to go to S4. Input A and output X. So that one is input A, and that one I believe is input capital X, I believe, not too sure. So that's it. This is how you do this question. And then another part of this says identify the input sequence that will cause the minimum number of state changes in the transition from S1 to S4. Now you can also take a look here. I mean, you can also take a look here from S1 to S4, minimum number of state transitions. You can go back and see here S1 input B, this is the biggest path, input B. You're going to S2 and then another input A, taking you to S4. You know, this one was taking another input B, input A. So it has asked question, the input sequence that will cause the minimum number of state changes in the transition from S1 to S4. You could have said input A, I mean input B, again input B, input A and input A, if you would transit from S1 to S2 and S5 and then S2 and then S4. But I mean, we are not fools, so we would look at this, that so the minimum inputs, input B and input A, this one, see, this one and this one is the minimum number of inputs for us to take from S1 to S4. Alright, so you would write it this like this. I hope I don't have to open the answer key. You can say input. Now you have to see how I write. My handwriting, it doesn't go very good on this touch laptop with finger. I would be using a stylus next time. And then input B. Oh, sorry, first one was input B and then it was input A, so sorry. Alright, so that's it for this one, and I'll come up with the next video when we would do this vice versa. Thank you so much.